Okay, so now that you understand how to change speeds with the robot and get the robot to change directions and turn using the set motor speed command, um, here's your first project to work on. Uh, this is a simple square project. Your robot starts in the starting gate. It's going to need to turn right to go to this direction and then make a square driving around the four walls. You see a wall here, 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 and here. The task is to make a circuit around the track without hitting the four walls and make it back to the starting block. You don't need to end up completely in the starting block. As long as you touch the starting block, that would be a successful completion. So let's talk a little bit about how you can get from the starting block around the track back to home base. By the way, we don't care if you start out right or start out left as long as you get back and go around the circuit. All right, so let's look at the code. You hopefully remember this from our previous um, program. Set motor speed is going to tell the robot how fast to go. We have two motors. We have a left motor and a right motor. We have at the start had the left motor going forward and the right motor going in reverse. If the left motor goes forward, that's actually going to turn the motor to the right. So we're going to introduce you to a new coding procedure called comments. If I enter two forward slashes. Not sure how good your screen is, but those turn green. These are called comments. They don't actually affect the program. They just tell people what the program is supposed to do. So in this case, what comes after these three lines together should make the robot turn right. Don't forget, 25 means 25%, and negative 25 is negative 25%, so it's going to go in reverse. And so this is going to go pretty slowly, and we just entered sort of a small number because we thought it'd be a little bit easier to control. Sleep tells it how long to make this turn. So these two are making the robot turn, and this is saying 750 milliseconds, so 3/4 of a second. Now we see the next bit of code. We set the left motor to 25 positive and the right motor to 25 positive. So that should go straight. And how long? 3,000 milliseconds or 3 seconds. So we'll say go straight. And this is the first, first leg. Now, what happens after that? If we look back at our field, we need to turn right, then we need to go straight, then we need to turn this direction. That's turning left. So up here we noticed positive 25 for left motor, negative 25 for right motor. We're going to do the opposite. Negative 25 for left, positive 25 for right, and in this case we just wrote 1,000 because this is trial and error at this point. So we'll call this turn left, and this is the first corner. And then we're going to go straight again. So we'll say straight. Second straight away. You can write whatever you want so that you remember what it is. And this is 25 and 25. Let's increase the speed to 50 and 50. And because this is a pretty long distance all the way down there to get past this corner so we can go and make the next turn. And we'll increase this to 2 seconds. So now we've written our program. We're going to turn right to start and move so that we're pointed this direction. Then we're going to go straight for the first leg down here just to get into this corner, and that's for 3 seconds. Once we get here, we're going to turn left so we can go that direction. We did that for 1 second, and then our second straightaway going up here was 50, a little bit faster, and we did that for 2 seconds. Now we can compile the program, and we can say download to the robot, and we'll run the program and see what happens. It turned. It's going forward. But it didn't go forward long enough. Now it's going forward again. So what was wrong? The first turn seemed to be close. It didn't quite turn. We might have liked it to turn a little bit more. Going back up to our program, here's that first turn right. Well, that wasn't enough. So we could increase the amount of time it was turning up to a full second. Or we could have increased the speed at which it turned. Now, this first leg, do you remember? Did it go far enough? It did not. So let's increase this from 25 to 50. And we'll leave that at 3,000. The turn, I can't really remember if you were doing this on your own. You might want to take notes just to determine whether we thought that was enough. But this second straightaway wasn't nearly enough. Let's increase the amount of time it goes to 4 seconds, and let's raise that all the way up to 75, and let's see what happens. Now we're going pretty fast, and we're going for 4 full seconds. We compile it. We download it. And now we run it. Does it turn enough? A little bit too much this time. Does it go far enough? Not quite far enough. Does it go far enough that way? Oh, it ran into the wall, so we don't even know. Let's go back one more time. What was wrong? The first turn right was a little bit too much. Let's make that 900. Hopefully that won't turn too far. This first leg, maybe not quite enough. Let's try 3,500. And let's compile. And download. And let's look at this from overhead. Run it. It turned just about right. Does it go far enough? It goes just not quite far enough, and it turns a little bit too far. So here's where we got you. This amount of time and speed was enough. That was almost a perfect turn. The first going straight, not quite far enough. We could increase the speed, or we could increase the amount of time to get it past this wall so that it's going up here and not running into this wall. We need to get farther out here so we can go up this lane. Then you can, the turn looked like it was a little bit too much. Maybe we're going to decrease that. Then you can start looking at your second straightaway. The project is get all the way around the 4 corners and back home.